Okay, so let us continue chapter 11. We're going to talk about power series definition. A power series is defined this way. The sum of some coefficients like C sub n times a variable like x raised to power n. N starts, let's say, from 0 and goes to infinity. So C sub n, these are just some numbers or constants. There you go. We can write the power series in expanded form, C sub 0, x sub 0, plus C sub 1, x to the first power, C sub 2, x to the second power, and the rest of them. So, of course, x raised to 0, with the condition that x is not equal to 0, is just C sub 0, plus C sub 1, x, plus C sub 2, x squared, plus the rest of them, or in compact form using series, the sum C sub n, x to the n, n starts from 0, goes to infinity. So this is your power series. So we can expand this definition and write it in general form. In general form, a power series can be written as the sum C sub n x minus x sub 0, which is just another number raised to n, n starts from 1 to infinity. X sub 0 is another constant. So if you write this power series in expanded form, you get C sub 0, C sub 0, x minus x sub 0 to the 0 power, plus C sub 1, x minus x sub 0 to the first power, plus C sub 2, x minus x sub 0 to the second power, and so on. With the condition that x is not equals to x sub 0, you get C sub 0 plus C sub 1, x minus x sub 0 plus C sub 2, x minus x sub 0 to the second power, and so on. General form of a power series. Okay. So I expect you to ask, if we have a power series, when the power series is convergent, when it's a divergent series. Very well. For a power series written as the sum C sub n, x minus, instead of x sub 0, suppose we use a constant, you know, that x sub 0 is just a number, so let's call it a raised to n, n starts from 0 to infinity. If the absolute value of x minus a is less than a constant, a number like r, then we have a convergent power series. So how do we find this r? We're going to get back to previous section and actually use the ratio test. So to find R, you use the ratio test, which was the limit of absolute value of an plus 1 divided by an while n goes to infinity. Very well, let's go over one example to see what's going on. Example. Suppose you have this power series. Your goal is to find the radius of convergence for the series, which is defined this way. The sum -3 to the n times x to the n divided by square root of n plus 1, and starts from 0 and goes to infinity. Okay, very good. So let us use a ratio test, which says you need to form the limit of an plus 1 divided by an while n goes to infinity. Remember that this one was equal to L, and if L is less than 1, you say that you have an absolutely convergent series. If you have an absolutely convergent series, then the series is going to be convergent. Okay, keep that in mind. So let us form the limit of absolute value of an plus 1 over an while n goes to infinity. You get the limit of absolute value of -3 raised to n times -3 times x to the n times x divided by square root of n plus 1, which is n plus 2, divided by -3 to the n times x to the n divided by square root of n plus 1. Note that everything is inside the absolute value. So of course we can cancel out some of the terms here. We can cancel out -3 to the n, -3 to the n, x to the n, x to the n. Very well. So here you have the limit of absolute value of -3 times x times, let us flip these two, square root of n plus 1 divided by square root of n plus 2, while n goes to infinity. Okay, as you all know, since n plus 1, n plus 2 both have exponent a half, so they go to infinity with exactly the same rate. So you can cancel out these two, and this is equal to 3 times absolute value of x. This is your limit. Very well. This is your L. And you know that if, this is my L, so I'm going to write it here, L is equal to 3 absolute value of x. You know that if L is less than 1, we learned it before, then you have an absolutely convergent series. So if you divide all sides by 3, absolute value of x must be less than a third. Or radius of convergence is equal to a third. 1 over 3. And in this case, note that your A is 0. So when we have a power series, of course we can take the derivative, we can take the integral, because it's just a new function. So a power series of the form sigma Cn x minus a to the n and starts from 0 to infinity. Suppose it's convergent over x minus a less than r. Suppose you have the radius of convergence r. Then we have a new function. Of course, it's a function. You have variable x with variable x. You define a function dependent on x. So you can write it this way. F of x is equal to the sum Cn x minus a to the n and starts from 0 to infinity. Or you can rewrite this new function as a polynomial, or if you have negative exponent, with a format of a quotient function. So f of x is c sub 0 plus c sub 1 x minus a plus c sub 2 x minus a squared plus c sub 3 x minus a to the third plus the rest of it. Okay, since I have a function, I'm allowed to take the derivative of this function, find the rate of change, and also take the integral. We can differentiate this function. We can find the first derivative, second derivative, third derivative, and so on. So the first derivative of the function is equal to the derivative of constant is 0 plus the derivative of c sub 1 times x minus a is just c sub 1 plus 2 times c sub 2 x minus a plus 3 times c sub 3 x minus a to the second power and so on. We can take the second derivative of the function, 0 plus 0 plus 2 times c sub 2 plus 6 times c sub 3 x minus a plus the rest of it. And you can continue this process by taking the rest of the derivatives here. So let me rewrite this here for you. And you see how we drive to a formula. So suppose you have your function f of x, c sub 0, c sub 1, x minus a, c sub 2, x minus a squared, c sub 3, x minus a to the third, plus c sub 4, x minus a to the fourth, and you can take the first derivative of this function, which is 0 plus c sub 1 plus 2 c sub 2, x minus a plus 3 c sub 3, x minus a squared plus 4 c sub 4, x minus a to the third, and so on. The second derivative of the function is 0 plus 0 plus 2 c sub 2 plus 3 times 2 c sub 3 x minus a plus 3 times 4 c sub 4 x minus a squared plus the rest of the terms. Let's take the third derivative of this function as well. 0 plus 0 plus 0 plus 3 times 2 times c sub 3 plus 3 times 4 times 2 c sub 4 x minus a to the first power and so on. Okay. Take a look at these numbers. So here you have one. The first derivative, 1 times c sub 1. The second derivative, 2 times c sub 2. The third derivative, 3 times 2 c sub 3, and so on. There is a pattern here that you can simplify this pattern by substituting a. This is going to be c sub 1, 1 times c sub 1, f double prime at a is equal to 1 times 2 c sub 2, and the third derivative at a is going to be 2 times 3, 1 times 2 times 3, c sub 3, and so on. Okay, so in general, you can say that the nth derivative of the function at a is equal to 1 factorial, 2 factorial, 3 factorials, so you get n factorial times c sub n. The nth derivative of the function evaluated at the center a is n factorial times c sub n. So if a question says find c sub n, we can write c sub n as the nth derivative of the function evaluated at a divided by n factorial. Okay, now that we derived a formula for the coefficient c sub n, let us just rewrite our power series using c sub n as the nth derivative of the function divided by n factorial. Okay, so our power series f of x is defined as sigma c sub n x minus a to the n starts from 0, goes to infinity, which is now can be written as the sum of the nth derivative of the function at a divided by n factorial x minus a to the n. And n starts from 0, goes to infinity. So you can write f of x this way. If I write this in expanded form, if I plug in 0, I get the 0 derivative of the function at a divided by 0 factorial times x minus a raised to 0 plus the first derivative of the function at a divided by 1 factorial x minus a to the first power plus the second derivative of the function at a divided by 2 factorial x minus a to the second plus the rest of them. So the 0th derivative of the function is equal to the function itself. This is f of a. This is 1 plus f prime at a divided by 1 factorial, which is just 1, x minus a plus the second derivative of the function at a divided by 2 factorial, x minus a to the second plus the rest of it. So any function, this formula is important. Why? It says that any function has an approximation like this. This is approximation of function f of x. Very well. Okay. Note that if a is equal to 0, then we say that we have a Taylor series. Then this approximation is called Taylor series of the function. And in this special case, we call it Maclaurin series. Maclaurin series. So let's call it in general the Taylor series. So Taylor series. And if A is equal to 0, then you should just call it Maclaurin series. Okay. It's better to write it this way. Okay, since we are using an approximation, we always end up with an error. Error of the approximation. So if the n plus 1 derivative of your function has upper bound, like m is just a constant and it's the upper bound for the derivative n plus 1 derivative of the function. So this is just a constant and it's an upper bound. Then the remainder, or just that error, the difference between the actual function and the approximation r sub n of x actually can be bounded between upper and lower numbers, which follows this. This absolute value is less than or equals to m over n plus 1 factorial times absolute value of x minus a raised to n plus 1. For example, suppose we have function e to the x, and our goal is to write down the approximation of that function. Okay, let me rewrite this function here for you. F of x equals to f of a plus the first derivative of the function evaluated at a divided by 1 factorial times x minus a plus the second derivative of the function evaluated at a 2 factorial times x minus a to the second plus the rest. So example. So in this example, the question says, find an approximation for f of x. You have exponential function e to the x about a equal to 0. So here you can say that I want to find the Taylor approximation, or you can say since a is equal to 0, it's Maclaurin approximation. Both of them are absolutely fine. So e to the x can be written as e raised to 0, I'm just following the formula, plus the first derivative of function e to the x is e to the x raised to 0 divided by 1 factorial x minus 0 plus the second derivative of e to the x is also e to the x, so you get e to 0 divided by 2 factorial x minus 0 to the second. You can continue this process. The third derivative of e to the x is e to the x, e to 0 divided by 3 factorial x minus 0 to the third plus the rest of the things. So e to 0 is just 1 plus 1 over 1 times x plus 1 over 2 factorial, which is 2, x squared, plus 1 over 3 factorial, which is 6, x to the third, plus the rest of it. So e to the x can be written as 1 plus x squared over 2 plus x cubed over 6 plus the rest of the terms. Okay, another function for you. Suppose you want to write approximation for function sine. F of x is equal to sine x, and a is equal to 0. There you go. So f of x or sine of x is equal to sine at 0 plus the first derivative of sine, which is cosine at 0 divided by 1 factorial x minus 0 plus the second derivative of the function. The second derivative is the derivative of first derivative. The derivative of cosine is minus sine, so you get minus sine at 0 divided by 2 factorial times x minus 0 to the second plus, now we are taking the derivative of negative sine, which is cosine, negative cosine at 0 divided by 3 factorial x minus 0 to the third plus the rest of the terms. So function sine can be written as sine of 0 is 0 plus cosine of 0 is 1, 1 divided by 1 times x plus cosine of 0 is 0 minus cosine of 0 is 1, 1 over 3 factorial x to the third plus the rest of the terms. So sine x is x minus 1 over 3 factorial x cubed plus the rest of it. So in general, you can write sine as sine of x as the sum, negative 1 raised to n, x raised to 2n plus 1 over 2n plus 1 factorial, n starts from 0, goes to okay, let us write the approximation for cosine function. Now you have f of x equals to cosine x. Okay, let us follow the formula. Cosine x is equal to cosine of 0 plus the first derivative of cosine, which is negative sine at 0 divided by 1 factorial x minus 0 plus the second derivative, the derivative of negative sine is minus cosine at 0 divided by 2 factorial x minus 0 to the second power plus, now we take the derivative of negative cosine, which is positive sine, sine 0 divided by 3 factorial x minus 0 to the third plus, we take the derivative of sine, which is cosine, cosine of 0 divided by 4 factorial x minus 0 to the 4th, and we continue this process. So cosine function, cosine of x is equal to cosine of 0 is 1, this is 0, of course this is 0, cosine is 0, you get minus cosine of 0, which is 1 over 2 factorial, x to the second. As you can see, you get even exponent, plus cosine of 0, 1 over 4 factorial, x to the 4th, plus the rest of the terms. Okay, you can simplify this and rewrite cosine of x as the sum, negative 1 to the n, x to the n, x to 2n, divided by 2n factorial. And starts from 0, goes to the